Voltage drop is the reduction in voltage that happens when electrical current flows through a conductor. The amount of this voltage reduction depends on several factors, including the size of the conductor, the length of the conductor, and the amount of electrical current flowing through it. The National Electrical Code, or NEC, specifies the maximum number of conductors that can be installed in a conduit, and this is based on what is called the conduit fill. For example, a 3/4-inch conduit can contain up to 6 number 12 conductors or 3 number 10 conductors. The NEC also allows for the use of a derating factor to account for voltage drop when multiple conductors are installed in a conduit. The derating factor reduces the allowable ampacity of each conductor when more than 3 conductors are installed in a conduit. Impedance is the total opposition to the flow of current in a circuit. It includes resistance, inductance, and capacitance. Twisting conductors together to reduce impedance is not a generally recognized method for increasing the number of conductors that can be installed in a conduit. Here are some NEC sections that address voltage drop and conduit fill. Section 310.15b3 specifies the maximum number of conductors that can be installed in a conduit based on the conduit fill. Section 310.15b3 allows for the use of a derating factor when multiple conductors are installed in a conduit. Section 310.15b3 provides an exception for conductors that are pre-twisted to reduce impedance. However, this exception is only applicable in certain specific cases, such as when using shielded cables. The statement that it is only permissible to install 3 conductors in a conduit due to voltage drop is incorrect. The NEC allows for the installation of more than 3 conductors in a conduit, provided that the appropriate derating factor is used to account for voltage drop. There is no specific table in the NEC that provides guidance specifically for installing more than 3 conductors in a conduit. The reference to impedance loss in pre-twisted conductors is not generally supported by the NEC for standard wiring methods. Let's delve deeper into the concepts to provide a clearer understanding. Firstly, conductor size plays a crucial role in voltage drop. Larger conductors have lower resistance, resulting in less voltage drop for a given current. The NEC specifies minimum conductor sizes based on the ampacity requirements of the circuit. Secondly, the length of the conductor is directly proportional to voltage drop. Longer conductors will experience greater voltage drop than shorter conductors carrying the same current. This is why it's essential to minimize conductor lengths whenever possible, especially in long circuit runs. Thirdly, the amount of current flowing through the conductor significantly impacts voltage drop. Higher currents result in greater voltage drop. Therefore, it's crucial to accurately calculate the expected current draw of the circuit and select conductors accordingly. Conduit fill refers to the percentage of space inside a conduit that is occupied by conductors. The NEC sets limits on conduit fill to prevent overheating and ensure proper heat dissipation. Exceeding the allowable conduit fill can lead to reduced conductor ampacity and potential fire hazards. The derating factor is a multiplier applied to the allowable ampacity of conductors when multiple conductors are installed in a conduit. This factor accounts for the increased heat generated by closely spaced conductors. The NEC provides tables specifying derating factors based on the number of conductors in a conduit. It's important to note that the derating factor only applies to the ampacity of the conductors, not the voltage drop. Voltage drop calculations must still be performed separately to ensure compliance with NEC requirements. Impedance, as mentioned earlier, is the total opposition to current flow in an alternating current circuit. It consists of resistance, inductive reactance, and capacitive reactance. While twisting conductors can reduce inductive reactance to some extent, it's not a recognized method for increasing the allowable number of conductors in a conduit. The NEC primarily focuses on conduit fill and ampacity derating to ensure safe and reliable wiring installations. Now let's discuss the NEC sections in more detail. Section 310.15b3 provides the allowable conduit fill based on the type of conduit and the size and number of conductors. This section includes tables that list the maximum number of conductors permitted for various conduit sizes. It is crucial to consult these tables to ensure compliance with NEC requirements. Section 310.15b3 addresses ampacity derating for conductors in raceways or cables. This section specifies the derating factors to be applied based on the number of current carrying conductors in the raceway or cable. The derating factors reduce the allowable ampacity of the conductors to prevent overheating. Section 310.15b3 provides an exception for conductors that are pre-twisted or bundled in a specific manner to reduce impedance. However, this exception is limited to certain specific applications, such as shielded cables or specialized wiring assemblies. It's not a general allowance for increasing the number of conductors in the standard conduit installation. In summary, the inspector's assertion that only 3 conductors are allowed in a conduit due to voltage drop is not entirely accurate. The NEC permits more than 3 conductors in a conduit, provided that the appropriate derating factors are applied and the conduit fill requirements are met. While twisting conductors may offer some benefits in reducing impedance, it's not a substitute for proper conduit fill and ampacity derating practices. Always consult the NEC and other relevant standards to ensure safe and compliant wiring installations. Furthermore, consider that voltage drop calculations are essential to ensure that electrical equipment operates within its rated voltage range. Excessive voltage drop can lead to equipment malfunction, reduced efficiency, and premature failure. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To calculate voltage drop, you can use various online calculators or consult electrical engineering handbooks. The calculations typically involve factors such as conductor resistance, conductor length, and current flow. Remember to use the appropriate conductor resistance values based on the conductor material and temperature. Copper conductors generally have lower resistance than aluminum conductors. Also, consider the ambient temperature as it can affect conductor resistance. In addition to the NEC, other standards and guidelines may apply to specific wiring installations. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for electrical enclosures and equipment. These standards provide guidance on proper installation and maintenance practices. It's also crucial to follow manufacturers' instructions for electrical equipment to ensure safe and reliable operation. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. Bonding ensures that all metallic parts of an electrical system are electrically connected, minimizing the risk of voltage differences and electric shock. The NEC provides detailed requirements for grounding and bonding. Always follow these requirements to ensure safe electrical installation. Regular inspections and maintenance are crucial for maintaining the integrity of electrical systems. Inspections can identify potential hazards and ensure that the system is operating within its design parameters. Maintenance activities such as tightening connections, cleaning equipment, and replacing worn components can prevent failures and extend the lifespan of the system. It's recommended to establish a regular inspection and maintenance schedule for electrical systems. Qualified electricians should perform all electrical work. Electrical work can be dangerous and should only be performed by individuals with the necessary training and experience. Always de-energize circuits before working on them and follow lockout/tagout procedures to prevent accidental re-energization. Use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and arc flash protection as required. In conclusion, understanding conduit fill, voltage drop, and NEC regulations is essential for ensuring safe and reliable electrical installations. The NEC provides comprehensive guidance on wiring practices and should be consulted for all electrical work. Always prioritize safety and follow best practices to prevent electrical hazards. Remember to use appropriate conductor sizes, apply derating factors when necessary, and perform voltage drop calculations to ensure compliance with NEC requirement. Regular inspections and maintenance are crucial for maintaining the integrity of electrical systems. If you have any questions or concerns about electrical work, consult a qualified electrician. They can provide expert advice and ensure that your electrical system is safe and compliant. Also, the information about pre-twisted wires, impedance, and the tables in the NEC is something that doesn't have anything to do with the tables or pre-twisted wires, because impedance is another subject.